When text data feels like a pile of documents, BERTopic turns embeddings into readable themes you can inspect and explain. You'll see how to connect the pieces into a workflow that maps team documents into labeled themes. I'm Professor Pi, teaching AI foundations with simple Python. Start with the problem. Teams collect incident reports, user feedback, release notes, and customer quotes. That pile is hard to scan and even harder to summarize into action. BERTopic is a practical way to turn those lines of text into named themes you can review, filter, and hand to a product manager or engineer. It leans on pre-built sentence embeddings for meaning, then finds groups and extracts the words that define them. Intuitively, BERTopic does two things. First, it converts each sentence into a point in a geometric space, so similar sentences sit near each other. Then, it clusters those points and extracts the words that best describe each cluster. Strengths include handling short texts and giving human-readable labels. It does need sensible embeddings and a bit of tuning to avoid overly broad or overly fragmented themes. Quick preview of the build. We will create a tiny support corpus, compute sentence embeddings, fit BERTopic, retune UMAP and HDBSCAN to reveal subthemes, and generate readable labels for each document. That flow mirrors how a team would go from raw tickets to a dashboard of themes that drive work. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Let us begin by staging the small corpus we will experiment with. This snippet builds a tiny corpus of deployment incidents and growth wins to anchor our experiment. Engineers often wonder how little text they can start with before turning on heavy embeddings. We deliberately mix outage reports with adoption gains, so the eventual clusters have something to separate. The variable docs reads naturally on screen, making it easy to trace each feedback thread later. The printed corpus size confirms 8 specific lines are staged, and the preview shows how the story begins. With the corpus visible, the next step is to turn those sentences into numeric vectors that capture meaning. This example loads SentenceTransformer to turn each feedback line into a dense vector. The practical question here is whether you can trust off-the-shelf embeddings before you touch BERTopic. We cache the encoder in encoder and call encode with normalized embeddings equals true, so cosine distances stay meaningful. Embeddings ends up as a compact matrix where every row matches one entry in docs, ready for clustering. The printout proves we now have 384-dimensional unit vectors, which is the sweet spot for MiniLM. Now that we have embeddings, we fit BERTopic to see what topics appear without extra tuning. This code fits BERTopic on our embeddings so we can inspect the dominant theme. The risk developers ask about is whether small corpora will collapse into noise or yield clear groupings. We pass min topic size equals 2 to BERTopic, so HDBSCAN has permission to keep modest clusters alive. Counts captures how many documents land in each topic, and getTopic lets us peek at the highest scoring words. The printed main topic row tells us which cluster survived and how many docs anchor it, backed by the top keywords. If the default fit groups too much together, we retune the dimensionality reduction and clustering parameters to pull subthemes into focus. This example retunes UMAP and HDBSCAN inside BERTopic to change how aggressively topics split. The decision point is how tight you want the manifold before clustering, especially when you suspect subthemes are hiding. Tuned UMAP shrinks neighbors and distance to keep related tickets closer, while tuned HDBSCAN drops min samples to 1. so small groups remain valid. We reuse fit-transform to compare tuned topics against the earlier run, then count unique non-outlier topics for a quick sanity check. The print statement shows how many topics are now active and which ID headlines the refined spread. With clusters refined, the final step is to give them names teams can act on. This snippet uses BERTopic's generate topic labels to summarize clusters with human-readable names. Teams often worry about how to narrate the clusters without manually reading every keyword list. We map each tuned topic ID through labels so assigned holds a story-driven tag for every document. Counter then tallies which label appears most, and the short comprehension excludes the outliers bucket to keep focus on real themes. The printout surfaces the winning label and counts its docs, signaling a ready-to-present theme summary. In a real project, that pattern would map to a daily pipeline. Collect new tickets, embed them, assign labels, and push counts to a dashboard. Product owners see top themes, engineers see frequent failure modes, and managers use the labels to prioritize investigations. Recap: BERTopic converts sentence embeddings into clusters and readable keywords. Use it when you need human-readable themes from short texts or logs. Caveat: embeddings and clustering choices change results, so validate labels with a human in the loop. Next step: tune UMAP and neighbors to control how tightly related texts cluster and see how topic granularity changes. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.